I'm sure you recognize a positive physics assignment here, and you know that he provides videos to go with them, but I felt like some of the things he did in setting up the problem weren't super clear, and so I thought I'd give you my short version too. Because this is a projectile problem, you see I'm going to break things into horizontal and vertical and treat them separately because they are independent of each other. Immediately, you know that there are a couple of things that you can put into place right away. The horizontal acceleration is 10 meters per second squared, and the vertical acceleration is constant through the whole thing. The horizontal acceleration is 0 meters per second squared. So that means that I don't have an initial and final that are separate. It's always the same. We also share the time to go up is the same as the time to move sideways. So going up, we know that as the ball rises right here, it will come to a stop, and then you can see the trajectory showing that it starts to fall back down on the vertical side. So we're going to treat half the time to go up is giving us a final velocity of 0. Our initial velocity going up would be this component of the motion that comes out of the cannon, and the time to go sideways is this component of our original motion. I've added in that the problem told us that the initial velocity coming out of the cannon is 33 meters per second. Now, in your horizontally launched projectile, that was in the horizontal direction, that given value, that how fast it comes out of the launch object. But in this case, we're not launching it horizontally. So we need to break that 33 meters into its horizontal and vertical components. We have a 56-degree angle here, and we know that this side, the horizontal component of that velocity will be our hypotenuse times the cosine of 56, and our vertical component is the opposite side of the launch angle, so we would use the sine function with the hypotenuse. Zeroing in on the math, when I plug that into my calculator, I'm going to consider the green one, the vertical one, as my initial velocity. So you see VI in the up and down Y direction is 27.4, and that would be meters per second. And using the cosine function for the adjacent side, I get 18.5 meters per second as my velocity initially in the horizontal direction. So now I can come over here and add these values to my table. This is 18.5 meters per second and 27.4 meters per second for the vertical. Now that I know 1, 2, 3 variables, I could solve for both time or distance using the appropriate formula. I would just have to select one, either distance with initial, final, and acceleration to solve in the vertical direction, or I could solve for time, and you know those equations. So if I want to find my distance, some of you will be very happy to have that equation back, where you can use V final squared equals V initial squared plus 2AD. Or if we want to solve for the time, we can now use V final equals V initial plus AT. And that will give us the time to go up. That's only half the time. Now, why is that only half the time? Well, this is when I have traced that the velocity of my ball in the vertical direction is 0. So that takes me from going really fast to slowing down and stopping. And this would allow me to calculate my height that the ball travels. But it would only take half the time, because once it stops, it continues going sideways as it falls back down. So the time that I get here, the time to travel sideways, I got that to be 2.74 seconds. But that's only the time to go up. Over here, we're going to go up and back down to get the range. So in order to deal with that, I would have to double that value. It was 2.74 to go up, and again it'll be 2.74 to fall back down the same distance. That total time would allow me to have my range. That range is known as the distance to travel from where we started to where the cannonball lands. That's the range. And because we have no acceleration, we know we're limited to one equation. Velocity is equal to distance over time. So here we have a velocity of 18.5 times the time, that would be the total of 5.48, would give me my total distance. Punching that in my calculator, 5.48 times 18.5 gave me a range of 101.4 meters. 101.4 meters is my range. And that's how I resolve each of the parts of a horizontally launched projectile.